Hello. Hello, Keiko. Can you hear me?
Yes.
I can hear you also. Glad to have you today. Have you tried the questions that uh, the one
The Maclaurin, is it?
the angle and everything. Have you tried
Oh,
it?
yeah.
So
It's okay, yeah.
it is correct, is it?
Yeah.
All right. So it turns out that that's still the standard way of handling division. It must have appeared. Maybe we cannot see it directly, but because through experience should you convince you that the power minus one binomial it should be a standard way of trying to handle the division, at least for the first attempt. Oh. Right. I will appear quite tired today. Yes, been a long day. Okay.
Okay.
So, did I owe you any other question?
No.
Okay. Have you tried a new paper? Oh,
I read one paper and I did one question.
right. Oh, right. So you have read it. Is there any questions from the reading first?
For vectors, right? If they give me distance between two planes, do I just assume that the planes are parallel?
Yes, because if they are not parallel, then they will intersect.
Okay.
It doesn't make sense to ask the distance if they intersect.
Okay.
However, they do usually make it clear that they are parallel also somehow. Right. So if there's any doubt there, maybe we should talk about it.
Then I'll just take a photo of the question.
Sure. And that would be go. Ailesh, can you hear me?
Yeah.
All right, I can see you also. Slightly earlier, right? I tried to call your mom, maybe she's busy, so right. Okay. So your video and your tablet, please. Keiko, is Kyoko at home today?
Yeah, she's free.
Yeah, because I thought she's joining us, right? Today is Tuesday. Yeah, it should be actually, right? So in another minute, if she's not joining, I will have to trouble you to just ask her, right?
Okay.
Right, thanks. You're taking a screenshot and you're putting at page 11. Right?
Yes.
All right. Okay. So your question is the part 4 and part 2, is it? Part 4.
It's more of reading.
I believe so, right? Okay. Yeah. So I guess they didn't tell you anything about plane pi 3, right?
Yeah.
Given that A, so A is there from the start, you have the small a already, I think.
A is just the x coordinate of A. Yeah.
A is just right. So plane pi 1 contains A, right? Pi 2, and this is from pi 2 and pi 3. Okay. So it is clear that pi 2 does not contain A, right? Okay, so Yeah, right. So let's just assume that. So the question does not tell you that. Okay, so we should assume this is parallel because that's the only way. Right, a good question. Okay, for question 6, part 2, what is your question?
Okay, they said there's this part. Then I don't know what this phrase means.
Right. It seems like a reading issue, right?
Yeah.
So, do you mind just checking with Kyoko, and then after you go back, hopefully I can answer you.
Okay. Hello.
Yes. Hi. Hey, hi. Kyoko, is it?
Yeah.
Oh, you're using Keiko's. Yes. Kyoko. Yes, Kyoko. Are you joining us today?
I thought it was on Sunday.
On Sunday. Wait. So this week only once, right? We only met once, right? Yesterday, right? Am I correct? Wait, am I correct?
Hmm?
Yeah, correct, right? We only met once, right? Yesterday, right?
I didn't
Or
I meet you on Tuesday.
do I meet you?
Eh?
I don't know.
I did.
Mm, wait. Am I blurred? Am I being blurry here? Do I? No. Oh, wait. Yes, I did meet you at 20. Wait.
Yesterday and either Monday or Tuesday. Tuesday at
29, right? Yeah, no. 29 is Tuesday. Oh, goodness me. So we didn't synchronize. Oh, we didn't synchronize our Tuesday. Okay, that was my fault. That must be because it was the first time. Oh dear. So, but you did completed your 3 hours, right?
Hmm.
Today's Thursday. Very well then. All right, for now. Yeah. I think we still have time to. Let's say we start on Sunday. Sorry, let's say we continue our differentiation on Sunday. I think at that point I will know if it is too slow for you or not. Then that means if it is too slow, then I'll request for more time, right? But we have enough weeks lah for me to request lah. Okay.
Okay.
All right. So I guess we don't have to meet first today. Okay. All right.
Okay.
All right. I'll see you on Sunday.
Yeah.
Okay. Thanks, Kiko. So Ainesh, if you don't mind, since Kyoko is not joining us today, then we will discuss the other things lah, not the differentiation and integration.
Science.
Right, okay. All right. Yeah. It can be science. It can be the whole math. Right. So there's a lot of options there. Okay.
I guess we can do science.
All right then. But the homework first lah, or math lah. So yes, yesterday's homework lah, right? Okay.
Yeah, so what I did was
Take
since
a
I haven't
picture.
done it in a long time, I decided to do a bit of log from my book. That was quite difficult. So I referred to the answer sheet to like how I'm supposed to do some of the questions.
Right. All right. Let me just speak to Keiko very quickly, then I'll check your log. Yeah. So Keiko, I'm still not getting it yet. So leave it to me. I'll try to absorb it. I'm not sure what it means right now. Right?
Okay.
Right. Is there anything else besides this one? Reading issues.
I don't think so.
Right. Then do you feel ready to do it lah, under the time constraint again?
Yes.
Okay. What paper is this? Sorry, whose paper is this? What school?
Nanyang. Still
Nanyang
Nanyang.
again. All right. So okay, still the same standard lah. Right. All right. Then feel free to do, and and pause if you want to ask me again. Right. Right. So Ainesh, so I see that you did some papers, and this is from which book?
This one.
Oh, that book. All right, understand. Right, understand. So you're not using papers. That's okay. So, right. So show me the things that you did for yesterday's for the 30-minute homework.
All of this took me almost an hour, so I assumed it was both days because it took me really long. They're very tedious. These are some tedious questions.
So again, show me properly like 35. Right? It's blocked right now. Right, understand. Okay. Shift to the right, please. Shift to the right. Okay. Shift to the right. One paper each, please. Shift to the right. Okay, thank you. Right. Okay. Right, keep it there. Thank you. All right. Right, looks good to me. I understand 38. I understand those are in this question. That's totally fine. Then 36. That's fine, but 35, 38, 36 are the same type, right? So I guess that's a good practice for you. Since you checked the answer key, then I assume it's correct, lah.
Yeah.
Right, then 39. Let me see 39 for a while. What's 39 about, right?
It's very tedious.
Not sure I follow what 39. Oh, okay, I see. Right. It looks unnecessarily tedious, right? Oh, wait, no, oh yeah, I get it. Yeah, right. It still looks unnecessarily tedious. What's going on?
Yeah.
So you're saying that they end up canceling each other, almost everything. Everything almost cancels each other. Right. Not sure where this is coming from, but okay, 39. If you understand that, I have no comment. So good for you to practice this. Right? It seems a very unnecessarily tedious question. Right?
Yeah.
Okay, so moving on, I've seen this 4 question. Is there anything else on this?
I couldn't do question 40.
And can show me 40. Thank you. Right. That's 40. This is 40. Oh, 40 is the one on the left.
No, this is.
Ignore that. So 41 then. Right. So 41 looks. If I understand this correctly, 41 contains x and y. Oh, there are 2 equations. Sorry. So this is a simultaneous.
Yeah.
All right. So what's your concern with 41?
Question 40. I'll show you the question.
Right. So your 41 is fine, you're saying?
Yeah.
Right. Yeah. Those are tough-looking questions, right? Right now, I'm actually expecting your school to be less tough than what you did, right? So I guess that's good. If you could do it without the answer key. Now, I'm looking at a very small piece of question 40. I cannot see it right now. Right? So, right. Okay, right. Okay, for your textbooks, it's already too small. So I'm just going to ask you to take a picture using the tablet. Your writing, I can see. The textbook, I cannot.
Yeah, and my camera quality, I can't really do anything for this week.
Correct. So just use the tablet. Just use the tablet, right? That's what the tablet is for, right?
Yeah.
Right. You will use the holiday overview tree, right? Okay, so you're not going to use yesterday's Jamboard because that's just.
I already inserted in yesterday's Jamboard.
I'll
copy and send it, put in the other one.
Yeah, I'm not sure whether you can do it. So if you cannot, just take another picture.
Yeah. Oh, I can't copy it.
Yeah, we can't, for some strange reason, they don't allow us to copy across Jamboards. It's very weird. So we just have to retake the picture.
Okay. Okay, I put it in.
All right. Okay, I see it now. Now I'm gonna manipulate it so we don't clash each other. I'll just do the manipulation.
I don't see the picture.
And there you go. Okay, so again, your tablet should be on.
I don't.
So yes.
Oh, nothing.
So I can understand the question. So what is your concern with question 40?
I don't know how to do it. I looked at the answer sheet and I still couldn't understand.
Right. This question is when we read. So at the phase of reading, right? I always teach you, read first, try to understand the question. It's very weird because you have two unknowns, but only one equation. It's very weird that way. So don't manipulate. That picture is a flip. It's very difficult for you to manipulate. If you want to make it bigger, just help me. I'll make it bigger for you. Do you want to make it bigger?
Yeah.
All right, so I'll do that for you. But for this, because this photo was taken flip, it'll be very difficult for you. No problem. It's very difficult for you to manipulate. So is it okay now?
Yeah.
Right. So again, this thing is extremely weird because one equation but two unknowns. This is very rare. It can be done. It can be done, but it is very rare. Now, let me explain what this question means. It's actually a very simple question.
Oh.
Right, but it is rare and not seen, maybe not seen before. So it's a new experience for you. I hope you will remember it. So the key is that on the left-hand side, there is 5, of course, and on the right-hand side, there's also 5, right? That's the key lah. Okay. On the right-hand side, it's 5 power 1. Correct?
Yeah.
So to put it simple, the left-hand side must also be 5 power 1, no matter how complicated it looks. On the right-hand side, there is also 2 power 6, correct? On the left-hand side, there is also 2 to the power of don't know whatever complicated stuff, right?
Yeah.
So again, 5 power 1 is 5 power 1. 2 power 6 is 2 power 6. If that makes sense.
Okay. No, it doesn't.
Right. One more time. One more time. Left-hand side, right? Left-hand side. Left-hand side, can you combine the 2?
Yeah.
Can you combine the 5?
Yeah.
Then do so on paper. Do so on paper right now where I can see it.
All right.
Right now, I want to see a combination. It's pure in this skill, so nothing special in the skill wise. Huh? So let me see your skill. If the waste metal have no recycle, Focus on the left-hand side and combine the 2 power and the 5 power.
What is this?
Okay. Okay. Let's say I pretend I do not know it is right or wrong. I only see that you have combined all the 5s and all the 2s, right? Now, the most important rule in this, right? If the base is not the same, or if the power is not the same, there is nothing that you can do. What we mean by cannot do means usually is combining stuff, simplifying stuff. So it's just to repeat the obvious. You can combine the 5 power with the 5 power because the base is the same one. So you can do that, right? That's just being obvious. You can combine the 2 power with the 2 power because, well, the base is the same. Again, stating the obvious. So far, so good.
Okay, yeah.
But the thing in front of you right now, the final one, I'm gonna pretend that it's correct, right? I say I don't know what is correct. Can you actually combine them even further?
No.
And why is that so?
Because there's no similar base or power.
Or power. You're right. Again, stating the obvious. If you think that's correct, then you are certain in your index. That is the most important rule. So this left-hand side, still left-hand side, is going to be equal to the right-hand side. Now, the right-hand side looks like this in the Jamboard, correct?
Yeah.
Can they also combine? Any chance for them to combine?
I guess. No, wait. No, there's no chance of mine.
For the obvious reason that
There is no base, no power.
no, the base or the power is not the same. So you have to say that. Okay. So right now, the situation of the left-hand side and the right-hand side is not simplifiable, right? It's not simplifiable, but it is totally comparable. It is totally comparable, don't you think?
Wait, hold on. What?
Because the left-hand side cannot be simplified further for obvious reasons, the right-hand side also cannot. You're left with one option only, which is to compare the left and the right, right? I hope that makes sense. I hope that's how the question seems to confuse you, right? Yeah, something like that. Yeah, something like that. And then the other one. And then you have answers. So at this point, you'll get your answer and then you check your answer to know whether you're correct or not. Right? Because the way you do it is slightly unique, but I'm holding my breath right now. Right? I'm hoping that you're correct. I really hope that you're correct. Right? So put it in the calculator and I'm holding my breath. I'm hoping that you're correct. So Keiko, I'm still trying to understand. I'm not getting it right now. Yeah. You're muted. I just saying Keiko. Yeah.
I didn't say anything.
All right. So, yeah.
Mhm. Yes, it's correct.
Oh, wonderful, wonderful. Okay, very proud of you of your skill, right? Again, the reading of the question, I will classify this problem as a reading problem, if that makes sense to you, the understanding of the question, instead of any deficiency in skill. Your skill is fine, totally fine, right?
Yeah.
Okay. What do you think about the reading challenge, I would call it?
It was difficult, but I can see how it's possible.
Mhm.
You can understand.
Again, very rare, but notice that I'm guiding you with the basic principle of English. Look, can combine or not? Cannot. Can combine or not? Cannot. Then compare, look, something like that.
Mm-hmm.
Right?
Yeah.
So, in the off chance that this happens in exam, then I hope you will remember this.
Yeah.
Okay. So you haven't tried any log question. These are all in this question. In this question are known to be very tricky, lah, right? But don't over practice, lah. Don't over practice. If this is your homework and you're getting started, I'm okay. But starting today's homework, that means for tomorrow, for next Sunday, right? For the coming Sunday, don't over practice your English. Do the other topics also, lah. Right. Still, happy that you get some warm up.
Mm-hmm.
No, you do still owe me 1 hour of math homework. So never mind that first, lah. From the 2 days before, right? Because you said that you lost your paper. I still cannot accept that. Right? So, never mind that. For now, let's do science, right? Let's do science, right? Okay, so why don't we check out if we miss anything from the reactivity series slide before we declare it to be done. Right. So as per usual, share your screen lah.
Yeah.
Okay. Keiko,
Yes.
do you want to pause first? You must be doing it under time, right?
Yeah, sure. I don't know.
All right. So my guess is currently as good as yours lah. I cannot improve upon your guess lah. I'm guessing that B is equal to 0. That's what it means. Because when I think of it, there is no other interpretation that I can come up. And if I compare it to part 3, that also seems to be something that makes sense, right? The thing that convinced me is because when I look at the 6 mark, that means the first part of the question, right? The hardest part, it already takes into account B. So it already takes into account that I can sell the waste metal. If that makes sense?
Yeah.
I mean, the B is there. So the question part 2 seems to, to be asking me to remove that consideration. That means B equals to 0. That's your guess. So that's also my guess. So I'm currently not adding anything to your interpretation.
Oh, okay.
Just give it a try. Just give it a try that way. Right?
Okay. Thank you.
Okay. Right. So metals, right? Ainesh. So let's just scroll to the last few slides. This is a lot of page. Let's scroll to maybe page 70. Because I remember back then we went with thoughts. Page 70. Just to make sure that we didn't miss anything. So page 70. You can type in you can do that also. Okay, let's stop here for a while. Right, rusting. Oh, we definitely have not covered this. Let's go up. Okay, to page 60, maybe. Let's start at 60. Oh, yeah. Okay, let's go up again. Yeah, let's go up again. Yeah, let's go up to extracting of metal. So I think we have to talk about extracting of metal just to make sure for a while. Right? Yeah, that one, 14.4 lah. So you cannot do that. Yeah, you have to guess the page. Maybe, yeah, let's say, yeah. Okay, that's nice. Okay. Okay, so scroll slowly, yeah, scroll slowly, going down. Yeah, then let's go, yeah, let's go. Oh, we need to talk about this. Okay, let's go down a bit, Let's see how your teacher, okay, I understand. Okay, let's go down a bit. Okay, good. Let's go down a bit more. Yeah, okay, I'm gonna stop here. Let's go back to the, let's go back to the reactivity series page now.
Oh, all the way up there.
No, down there. There's one. Yeah, okay, stop here. Okay, so never mind electrolysis for what? Never mind, you're gonna ignore the word electrolysis. I'm gonna ask you to concentrate on reduction with carbon. Okay, and I want you to understand that this is nothing new. You already understand this. That's why I want you to get, right? So in this reactivity series, tell me, where is carbon? You should on your annotation, you should also allow me to annotate, and then you should put where the carbon and the hydrogen is, right? Because the reactivity series, as we know, contain carbon and hydrogen. Right, hydrogen is there, wonderful. And carbon is where? Right? Now, carbon is not Cu, carbon is not Ca, carbon is C. Now you have to remember that. So I'm reminding you from that. Good. Okay, C. Good. Now, is this a how to say this? C is above zinc, right? C carbon is more reactive than zinc, and then suddenly at zinc, reduction with carbon is mentioned. Is this a coincidence?
No.
Then what does it mean to be reduced by carbon? What does that mean?
I don't know.
I would say, like, you understand the word reduction because you discuss reduction, oxidation. You understand what reduction is. Can I say that?
Oh yeah, so to lose oxygen.
Right. So somebody is losing. No. Stop saying oxygen. Stop. Electrons. Somebody is losing electron. So being reduced is losing electron. You are not correct.
So I mean gaining electrons.
Yeah. So somebody is gaining electron, and that is caused by carbon. You understand? Reduction with carbon is I am being reduced by carbon, so I'm being gained electron, and carbon is the cause. So far, so good.
Yeah.
Which is kind of weird to say that, but yeah, but that's what's happening. So go up again. Go up. No, go up. Okay. So if carbon is reducing somebody, carbon will be what?
Less balanced?
No, carbon will be oxidized.
Oh, okay.
Does this make sense? Carbon is causing me to gain electron. Reduce that. So carbon will lose electron. That's just how it works. I cannot gain electron without somebody else losing electron.
Yeah.
So carbon is losing the electron, and I am gaining the electron. I'm being reduced by carbon. Therefore, the phrase electron transfer. The electron from carbon is being transferred to me. I hope that just makes sense. You lose money because you're giving it to me. That's simple. That's simple. You don't just lose money to thin air. Of course, that happens in real life. But in molecules, electron don't just get lost. It has to be given to somebody else. So it's not actually electron loss, it's electron being given to somebody else. It has to be like that. Electron cannot just disappear to thin air, and also I cannot just gain electron out of thin air. Okay. So far, so good?
Yeah.
So reduction of carbon implies all that. No? One more time. Zinc is being reduced with carbon. What is happening to zinc?
Sorry, can you repeat what you said? Zinc is being reduced. bicarbon. So
reduction with carbon, right? So zinc is being reduced by carbon. So what happens to zinc?
Gaining electrons
From
carbon.
Which is losing the electron, right? So and then iron and lead also. And for some reason, magnesium cannot do that. Carbon cannot lose electron and give it to magnesium. That's what we're trying to understand here. It has everything to do with the reactivity series. Now, the reactivity series I told you has a mirror image, right? So everything else below the gold will be the mirror image with the positive ion, correct?
Yeah.
So if carbon loses electron, what does that imply? A jump up or a jump down? You should be familiar with it right now.
If carbon loses electrons, it means it's jumping down.
Good. And then zinc gaining electron means what?
It's jumping up.
Which means zinc started out as zinc or not zinc?
Sorry?
Zinc
is
jumping up. So does that mean that zinc starts at zinc as zinc or not as zinc?
It ends as zinc.
Very good. It starts as
zinc minus. Sorry,
zinc 2 plus. It's a memory of memory. Zinc 2 plus.
Zinc.
And carbon starts as carbon or not carbon?
It starts as carbon.
Very good. So here's the implication here. In the natural world, zinc no longer exists as zinc.
Wait, sorry. I don't know if I remember this wrongly, but isn't it because the copper jump is bigger, right? So how did zinc convince copper to jump down?
Oh, okay. Jumping down is easy, right? Remember? Jumping down is easy and also making things happy, right? So carbon jumps down. Zinc jumps up, correct? That's our case here, right?
Oh,
so
okay.
Isn't the jump up lesser than the jump down? By a little bit, by a little bit.
Yeah, okay.
So it can happen, but magnesium, can carbon convince magnesium to do that? To jump
No.
up? Cannot. Right? So here's a few implications here. Zinc, iron, lead, copper, silver does not exist in the natural world as zinc, iron, copper, silver, and lead. It exists as their ions, zinc 2 plus, Fe 2 plus, Pb 2 plus, those kind of stuff. As a human being, this is just your feeling, I'm just asking you from your 15 years of experience as a living human being. Do you prefer Fe 2 plus or do you prefer Fe?
Fe 2 plus.
So you prefer iron, not as an iron, Fe, but as Fe 2 plus, which is not the iron metal that you know day by day one, It's iron Fe 2 plus. It's not a metal at all. It's basically rust. You prefer rust than the iron metal. That's what you're saying.
No.
Cannot be, right? Cannot be. Do you prefer Pb2 plus or Pb? You have never seen Pb, you have never seen Pb2 plus. I hope you will never see them because they are both poisonous. They are insidious and poisonous. So I hope you will never see them. But I'm asking you to extrapolate.
I wouldn't prefer the poison.
But both Pb2 plus and Pb are poisons. Both.
What?
Right? So they are very dangerous. Even worse than that, do you know what? Pb2 plus tastes sweet. It's even worse. So if you taste it, it feels nice.
I've been to an iron mine. Does that mean I've seen Fe?
But you have seen Fe in your daily life. You don't have to go to an iron mine. You don't have to. Plus, if you go to iron mine, you have a misconception here. Normal people should have this misconception. You as a chemistry student should not. You think carefully. You go to an iron mine, you expect to see iron metal. Is that the correct expectation or not?
Yeah, it is.
It is not.
What?
You are absolutely wrong. As a normal human, you are forgiven. But as a chemistry student, cannot. So we're learning. Yeah. If you go to the iron mine, you are expecting to see Fe in its natural state, correct?
Oh.
The natural state of Fe is not metal, it's rust. Because iron rust. Look, iron rust. When iron rust, it jumps up or jumps down? When iron rusts, it jumps up or jumps down?
It jumps. Iron rusts. It jumps up.
No, it jumps down.
Oh, okay.
Why? Because he is happy to do so. He wants to do so. Remember that? Everybody wants to jump down. Of course, metal want to lose electron. Of course. That's the metal's life goal, to lose electron.
It's a rust. Is iron in its original state or is Fe2+?
So you think carefully, right? Rust, you have to think, I want you to think, right? Rust is the natural state.
Yeah.
The state that the Fe wants, not what we want. It's obvious that we don't want rust. Okay? It's obvious. It's obvious that we want metal, but you have to think from the Fe perspective. Does Fe want to stay Fe or does Fe want to become Fe2+?
It wants to become Fe2+.
Because by losing electron, it gains the complete valence shell and then he's happy, right? That's the theory. Every metal wishes to do that, right?
Yeah.
So in its natural state, do you expect iron to be, iron or iron 2+?
Iron 2+.
Therefore, rust is iron 2+ or iron likely?
Oh, it'll be iron 2+. So that means
Yes.
you go to the iron mine and you get rust.
Yeah, you mine rust out of the earth. Rust. Because that's the natural state of iron.
Then what about
Not
salt
iron.
mine? What do you see there? Salt isn't even a metal.
Salt is not metal. So it is true that when you go to salt mine, you do get salt, but think carefully. Salt, as in let's do the most popular example, NaCl, right?
Yeah.
If you're not a chemistry student, you're forgiven to think that NaCl contains sodium metal. You're forgiven, but you're not a normal human being. You're a chemistry student. NaCl, the Na is Na or Na+?
Na+.
Natural state, right? The Na is jumped down. Natural state. Cl minus natural state, or has Cl jumped down? There's no Cl here. My point is, so see, same thing one. So the salt mine contains both Na plus and Cl minus in its most natural state, the state where everybody is happy.
But okay.
There is one exception to this rule. We're talking about mines, right? There are two exceptions. I just mentioned two exceptions. First exception is already mentioned here. Gold. Gold occurs naturally uncombined, meaning Au does not bother to jump down. Not much difference for him, is what he's trying to say. I can be Au, I can be Au2+, whatever, man, because the jump down is so small, it doesn't matter for him. So he just stick around as Au.
I see.
Does this make sense? So that's the phrase here, occurs naturally uncombined. When you go look for gold, you do get gold metal. That's it. That's it. That's all.
Flat as well.
Sorry, what is?
Platinum.
Platinum also, yes. Those super precious, super. It's difficult to say that as a precious metal. It's a super pure metal. Yeah, they don't bother to drop down. They don't bother. They stick with themselves. Right? So a rare trait. You're a chemistry student. You must understand this is rare. Another exception is carbon. Carbon is super weird. When we go to a coal mine, do we get C or do we get the C that jump down?
We get the C that jumps down.
No, we get C. It's super weird, carbon. Carbon is super weird. It's an exception to the rule. So when we go to coal mine, we get coal. Coal is the black thing that you can burn for barbecue, right? When you burn that black thing for barbecue, it becomes CO2, right? Ainesh, can you hear me?
Yeah, sorry. What do you just say?
The carbon that you burn for barbecue, the black thing, right? Okay, the black thing is coal. Right? When you go to coal mine, that's what you get, the black thing. Then you go to your barbecue pit, you burn it, and then it becomes CO2, correct?
Yeah.
PO2 is the C that already jumped down. That means the coal that you get has not jumped down.
So it reacts with oxygen and becomes
and jumps down. Yeah, and jumps down. And
Okay.
becomes a C that jumped down. So original state of C is very weird. It has not jumped down. That's not how everybody else do things. Everybody else, given time, the natural state, they will jump down. Carbon does not.
So carbon and gold, platinum.
Gold, platinum, understandable, right? No bother. But carbon is so high there, he does not jump down. That's why it's weird. It's very weird. Another form of carbon is called diamond, right? You know diamond is carbon, right?
Graphite also.
Graphite also. Graphite, diamond, carbon, all of them whole, all of them is C that jump down or C that does not jump down.
C that does not jump down.
Which is, again, weird. And that's why we study carbon a lot. We study carbon a lot. It's weird, it's useful, it's extremely useful, I would say. It's extremely useful. Right. Okay, the fact that C have not jumped down, and the fact that zinc, Fe, Pb all jumped down already. We must acknowledge a few things. We don't mind coal be burned. We don't mind that. Correct? We don't mind.
Yeah.
But we want Fe to return up. We want Fe to jump up. We want the metal Fe, not the Fe2+. I don't want rust. Obvious one. Cu has its own rust, though. Cu2+, though. Ag has its own rust, Ag+, you know. My point is zinc, Fe, Pb, all has its own rust. They already jumped down. I therefore sacrifice carbon for the sake of gaining those metals back to their metal state. I sacrifice coal for that purpose.
Okay.
That is the meaning of reduction with carbon, because C is very weirdly haven't jumped down. I go and ask him to sacrifice himself, go and jump down, so that the rest can jump up.
Yeah.
Methods of extraction. Okay, so far so good.
Yeah.
So on top there is called electrolysis. You don't know what's electrolysis, huh? But tell me, why is it not written as reduction with carbon?
Because carbon is below it, so it can't condense it.
Yeah. So even though carbon is there, you cannot sacrifice carbon for those metals, right? So by implication, getting those metals are harder by implication. Okay. Now go down to 2 slides. Oh, one slide, sorry, see here, hematite, right? So when you go to an iron mine, the Hallstatt one, for example, in Sweden, must be a tourist spot. Iron is extracted from...
Also salt.
Oh, it's a salt mine. Right? So let's focus on an iron mine. I don't think iron mine is very nice. That's why I don't think people as a tourist go there.
Yeah,
it's an
I
iron ore.
My uncle works there. So
I see. Interesting uncle working in Sweden. Interesting uncle. Right. So iron oxide. Look at the iron oxide. Most important ore of iron. Mined from an iron ore. Right. It looks black. I don't think iron metal looks black. Right? So is this Fe2O3? Is that Fe metal or Fe that already jumped down?
It's Fe that has already jumped down.
So tell me the oxidation number of this Fe then.
Two.
Positive 2, you mean positive 2? Is that what you say?
Yeah.
Wrong. Try again. Don't forget what you learned in your redox, please. Right? You should be doing simple calculation here. It's not +2. Keiko checking. Are you okay so far?
Oh, +3.
Very good. Keiko okay so far?
I slipped up in the differentiation application.
What do you mean by slip up?
Like I did it the normal way, but I didn't. Like this question, they're asking for net cost, but I went for surface area. Then I realized I made a mistake.
Oh, so you take longer to do.
Yes.
Oh my goodness, your reading is missing a bit.
Yeah.
You have to take into account the A and then the B also because you have to resell, right? You can resell. Oh,
Yeah. But I managed to solve it lah, but a bit of
good.
time there.
Yes, understood. So it's not a total slip up, but your reading could be better lah. Good for
Yeah.
you, good experience. Yeah. Good. Anything else that worries you?
So far, no.
Then I'll leave it to you. Okay, so back to you, Ainesha. So again, this is what you will get if you visit a real iron or iron mine, not the metal. Let's go down one slide. You need to see this blast furnace as something that makes sense, not as something that is only memorized. Then our talk make some sense. So look at this blast furnace. You have never seen a real blast furnace before. Let me just confirm that.
Yeah, of course.
Here they tell you that the blast furnace, I have to use annotation. Annotate with green. Coke. Coke is a very weird name for coal. Just take it as coal, right? The C here, let me just confirm. They tell you C, meaning the C already jumped down or have not.
Have not.
Good. The hematite, which is the iron ore, the Fe already jumped down or have not.
If he has already jumped out.
So does this make sense? The purpose of blast furnace is to make C jump down and to make Fe jump up. Look, simple, right?
Yeah. Okay.
Why?
Okay, that does make sense.
All right. So why is there limestone there? We're going to talk about it. But the limestone doesn't seem to serve any purpose right now. Doesn't seem to. Right? So this tall chimney light made of bricks refractory metal doesn't matter too much right now. Now, what I want you to see is this one. Now look at this. Molten iron. From the phrasing molten iron, tell me, is this Fe that already jumped up or have not?
Fe that has jumped up.
Right. So here in melted form, and this waste gas, I want you to venture a guess. What is the waste gas?
Carbon dioxide.
Very good. So this completes our understanding. Look, C will jump down and Fe will jump up. Okay. Your question mark is this guy. Why is this guy here? And what is this slide? Is there any other question mark from this slide for you lah?
What?
Again, I'm taking the liberty of guessing your question mark. Don't go up. I'm guessing that you don't know what the limestone is doing there. You don't know what the hot air is doing there, and you don't know what that slag is like.
Yeah.
But the hematite, the coke, the waste gas, and the molten iron all make sense. So?
I think I'm gonna guess.
Yes, please.
Guess for the hot air. It's so that the waste gas becomes carbon dioxide. I'm just guessing.
So when you're saying that, that means you're assuming that hot air is oxygen. It's not the other component of air that is important.
It is. It enriches oxygen.
So the hot air is needed to convert C into CO2, is what you're saying.
Yep.
Let's see whether that guess is correct. It is a good guess. Let's see. Any other guesses for the remaining two?
I don't even know what slag is.
And limestone, don't know what to do also. Correct?
Yeah.
Right. So if we can understand all that, no, don't do that. Slag is a very general term. If you just search for slag, you can come up with other things. So let's just stick to your slide. Don't worry. Yeah. So
Right.
if you understand slag and limestone from the next few slides, then your understanding is almost done. Make sense? Yeah?
Mm-hmm.
Okay. So clear all drawing. Let's go down one. Let's go down one. Let's go down again. Okay, stop here. Coke burns in hot air. The reaction is C plus O2 becomes CO2. Make sense?
Yeah.
Is this what you guessed?
Yeah.
Now, let me read this one more time. You think about it in your mind. I'm trying to make iron metal, right? I'm trying to make iron metal. That's the function of blast furnace, okay? The first step is production of carbon dioxide. Does that make sense to you?
No.
One more time. I'm making iron metal. I have hematite, right? The Fe2O3. My first step is to produce CO2 from C. It does not make sense to you, correct?
Yeah.
It should. This is C going down. It should.
But so I don't understand. Okay.
Tell me again. Tell me. Yes, tell me what you think.
So how does C going down because of oxygen have to do with?
The Fe going up.
Yeah.
Let me show you very soon. Let me show you, because this is the first step. I agree that it has not made sense, right? The only thing that seems to make some sense is that C jumped down, but where's the Fe, right? Where is the Fe? I'm not seeing the Fe.
It's separate.
Good, good. Let's go down there. Let's go down. Let's answer that question. Production of carbon monoxide. Interesting, eh? So look at the reaction. The CO2 reacts with more C, becoming CO, right? This has not made some sense, but this is what's happening. Production of carbon monoxide.
Mm-hmm.
You should learn previously that carbon monoxide is a very dangerous toxin. For human beings,
yeah, I know.
right? CO. And why is CO very dangerous for us? That means if you go into the blast furnace and you breathe in the air, you will most certainly die immediately. But people don't do that, of course. So why are we producing such a dangerous thing? Right? CO. Right? Tell me, how does CO poison you?
I have no idea.
CO poisons you by grabbing to your blood. What is the function of your blood?
To bring oxygen.
And CO2, mind you, both. Yeah. Oxygen to your body and CO2 out of your body. So his job is to grab both two things. CO grabs very tightly to your blood. What happens? He hijacks your blood. Therefore, your blood can no longer grab oxygen or CO2, both, which is fatal. So remember that CO is very grabby to your blood. And let's see, next slide. CO, next slide. There you go. Do you see that? We're using the poison. Poisonous to us, but useful to this.
But that is the gas. That's the waste gas.
The waste, no, the waste gas is not CO. No. If the waste gas is CO, that means the whole factory is dangerous. No. The CO is being consumed here. Look at that. The CO is being used.
But where is the CO coming from?
The CO comes from the second step. Look at the second step, second slide. Right? CO comes from C plus CO2. Where does the CO2 come from? The first step. First step. C plus O, burning the coke becomes CO2.
Carbon.
Burned by oxygen becomes CO2. But it is not escaping yet. It is not. Step 2, it burns further with C. CO2 burns further with C. Step 2, look at step 2. Step 2, see, CO2 burns further with C. There's so many C. It's full of C. It becomes CO. CO haven't escaped also. Step 3. CO, the poison, is being used to grab the oxygen from Fe2O3. That's his job. So now you get Fe low. This is where finally Fe jump up and C jump down. This is not as straightforward as it seems. This is when it finally happens. Look at that. Fe sink to the bottom, liquid, CO2 escape finally. Understand this reaction, please. Don't just memorize it. Ainesh, any question on this slide? The most important slide is this one. but it is not separable from the first two slides. It's not. Ines, can you hear me?
Yeah, no, I'm digest.
Yes, please digest.
Where is all the carbon coming from?
The carbon looks very small here and very few. In fact, the whole blast furnace is full of coke and hematite. It's full choke of coke. It's choke full of coke. The molten iron is very small part here. This is pyrite, all coke and hematite. This thing, this pyrite is all coke and hematite. Then it does not show. The picture here not so good one.
That's why it's better to have a URL.
Okay, go to the URL. Maybe he'll show you a real video of whatever. How come the URL cannot click? Good. Okay. No, this is already a steel production. Okay, before this. Okay. No. Let's go forward a bit. No, go forward a bit. Go forward a bit. No, still forward. He's not showing you the inside of the blast furnace. Okay, go forward a bit. And the metal is already formed. This is so annoying.
Oh, so they didn't show?
Yeah, he doesn't. Okay, I'm gonna show you another video. Okay. Make sure I have a better one. Wait. Let me send the link. This is not. Yeah, no, I lost the link. I'm gonna find it and show it to you later. Yes. Now, at this point, Ines, believe me first that that blast furnace is chock full of coke and hematite.
Yeah, okay.
In that sense, there is so little air and so many coke. So the CO2 that is formed initially escapes upward, correct? Escapes upward because the hot air is entering from down there. Make sense?
Yeah.
As the CO2 is produced, it goes up because it's a gas. It needs more coke because it's chock full of coke, right?
Yeah.
It becomes CO, and when it becomes CO, it needs hematite because it is also chock full of hematite.
Okay.
When it meets hematite, finally the iron is obtained and the CO2 can escape, no longer is needed. So the CO2 finally goes really upward and the Fe will go downward, therefore the molten iron. If that makes sense. That's why the hot air is blown from below, not from top. If you blow it from top, the CO2 escapes immediately without doing its job, so to speak. Okay, make sense?
Yeah.
If you can make sense, I'm asking you to memorize the three reactions together right now because they are one set. Memorize the three reactions immediately right now. I give you 4 minutes. Nico, are you okay so far?
Should be okay now.
Right.
The paper is just not very nice.
It is not, right? Your Nanyang paper is never nice. Never nice, right? Never nice. This is not meant to comfort you too much, but A-level is easier than Nanyang.
Yeah.
So whatever your Nanyang is worth, it is worth that. It is worth like your A-level will seem easy. because you're just used to this kind of thing, right?
But I guess I don't want to have like that kind of mindset also. Because I
Yes.
feel like that will stop me from improving.
Correct. That will stop you from doing your best for Nanya.
Yeah.
Right. Correct. Correct. So pretend I didn't say anything.
Okay.
Now, I must say your reading skill does feel like it improves. It does feel like it.
No, are you talking to me?
No. I was
Okay.
talking to your senior. Pardon my handphone. Answer. Ainesh, are you ready to, for the 3 reaction? Have you memorized them? All right.
Not yet.
Are you ready, Ainesh? Are you ready, Ainesh?
Yeah.
All right. Now, close your slide. Close it entirely so that you cannot see.
I'll just go here.
And go to the Jamboard, right? Oh, no. Close the slide again. Fully close the slide so that you're not tempted. Just close it. Close the tab. Close the tab.
Yeah, close.
Did you? No.
Oh,
Oh,
you
well,
mean close?
I guess kind of. You did kind of. Okay, good. Now, watch how I do it for a while. The way I do it is a mixture of memorization and understanding. Okay, watch how I do it in page 6 of the Jamboard. And then you can do it. Okay. I note that there are 3 reactions, right? Page 6, right? Okay. I note that there are 3 reactions. I note a few things. I note a few things. The last reaction should give me Fe and CO2. And the first reaction should somehow start with C. Okay. Also, I note that there's a Fe2O3 here. Right? Now, all this should make some sense to you already. See, I start with C, I start with Fe2O3, and I will end with Fe and CO2. That is the concept I already have in mind. Does that make sense?
Yeah.
Right. But you notice that I don't just combine Fe2O3 and C. That means you learn something. You learn that that's not how it works. the process is slightly more complicated than that now, which means you should remember Fe2O3 does not combine with C, but it combines with a certain thing. What is it?
Combines with carbon monoxide.
Right, the poison, the grabby poison, the grabby oxygen poison, right? CO, right? This tells you that CO must be produced by the second reaction for it to be used in the third reaction. Does that make sense?
Yep.
So the second reaction produces CO. Do you remember how CO is produced?
Carbon dioxide plus carbon.
Plus carbon. And do you remember how carbon dioxide is produced?
Carbon plus oxygen.
Yeah, so that's simple. That means the first one is simple. Right. This is a very good skeleton already that uses our logic and some memorization. The only thing left here is to balance, correct?
Yeah.
So try to balance it. And then if you balance it, then you are 90% done. There's one thing left to do. Yeah, the balancing of the last one is slightly difficult. Yeah, so.
Yeah, it is.
Oh wait, no, it is not slightly. No, it's not. Oh, wait.
No, it is.
Yeah, it is. It is slightly more difficult. So it's a good practice. It's a good practice. You cannot memorize the balancing anyway. You shouldn't. You should be balancing on the spot. So it's a good practice. Look, I told you the principle, right? You must balance the one and the one, right? The one on the left and the one on the right. So you start with the Fe, right? I feel that you start off well, right? The Fe is 2.
Yeah.
Your C, you now decided to be 3, right? So that's the hard part. The C works. How about the oxygen? Does the oxygen work?
Yeah.
Very good. Your balance is correct.
Yeah.
The remaining 2, the reaction, the first one and the second one, is it correct?
Yeah.
Good. You have memorized the 3 reactions. I must say that I think you should feel quite proud of yourself. You have never memorized reaction 2 well one before.
Yeah.
Right. Do you feel confident if I erase everything? No, you do it yourself?
Yeah, sure.
Yeah, correct. Yeah. All right. Now notice that I didn't do it like this. Oh, first reaction, then second reaction, then third reaction. I don't. I use some sort of logic, so I kind of it looks like I'm jumping here and there, but I'm not. I'm just following my logic. For you, it's up to you. You tend to do things straight one, but that's not always the best one logically. So I give freedom to you to do what you want. Now I'm erasing everything. Please use your tablet and write down the 3 reactions.
I can type it out as well.
If you want to.
Yeah, I'll just do with what I'm most comfortable with for now.
Yeah, but don't balance first. Balancing is the last thing to do, right?
Yeah.
Try not to balance first. Echo, okay so far?
Yes, but I definitely exceeded lah.
No problem. Have you noted where you are with the limited time? You noted that you take note, right?
Halfway through question 4, which would be the
That's fine. That's fine. Then
yeah,
you
the first question lah.
just
Yeah.
continue. When you mark, then you will note oh, by limited time I get this mark, and then after that I get how many marks after this, right? That's all, right? Easy peasy, right?
Okay.
There is no doubt that your Nanyang level of question takes a lot of time. There's no doubt.
Done. Hello?
Sorry, I was just taking my drink.
Oh, okay.
So let me see. I have here. Wonderful. Now complete it by stating the state symbol.
Oh,
Now use your logic. Use logic, not memorization. Do not memorize. Like logically, the C is cold, right? So cold is what? Solid, liquid, gas, aqueous. Like logically. Use logic, please. Right? Don't use memorization. Don't. Okay. Oxygen. Oxygen is what, right? Naturally. And then the CO2 is what? Naturally. See, first one correct. So far, so good. Second one. Right then. Right then. Good. Now, third one. That's a
I'm not
hematite.
sure.
What's hematite? What's iron ore? Iron ore naturally solid. Good. Then. Good. Then the CO2. Good. Then finally Fe. Now this a little bit of memorization. The Fe that comes out is super hot.
Molten.
Super hot until it's liquid. And so that's a little bit of memorization. That's all. So far so good.
Yeah.
You are 80% done in this blast furnace, right? No, 80% done. We have to talk about the slag thingy and the carbonate. Now, the reason this is important because your paper makes a big deal of blast furnace. When we go through last time, I was looking for the reactivity question, right? Cannot find, right?
Yeah.
Then I was saying, hey, the local school makes a big deal out of reactivity. How come your school does not? Okay, whatever. But I noticed that every time they give you blast furnace, your school, and it's a big question. So they make a big deal of blast furnace. I'm pretty sure when we come back to your paper and try to do some questions, that's what we're going to find. Okay. Any questions so far?
No.
Okay, let's go back to the slides. So we should find answers for the slag and the carbonate. I think page 47 or something like that. Just click on the page. Click on the page. There's a page number there that you can click. No, not down there, down, middle down.
I
Middle.
got this thing. Oh.
The thing, yeah. That. You should be able to click that and type 47. You cannot.
No, I can't.
That's weird. Okay, let's go to 47 then. Yeah, 47. Okay, let's go down. Right, you were here, you were here. Yeah, you were here, right? Okay, now the next slide. Removal of impurities. Let's stop here for a while.
How many removals are there?
Okay, what the heck is removal of impurities? What the heck is that? Let's stop here for a while. What kind of impurities are we talking about here? Let's talk about something that makes sense. Okay. The iron ore is, you've seen mines, huh? Are mines actually a clean place or a dirty place?
Well, I mean, the place I went to
was kind of clean.
It wasn't very clean, actually.
It's a salt mine, right? Salt mine, right?
The salt mine was very clean because it was a tourist attraction. But the iron mine was
dirty.
Yeah.
Do you expect the hematite iron ore, right? Fe2O3 to come out nicely packaged from the ground, right? Ready for us to use, right? So you expect it to be what? If it comes from the ground and I'm digging it with
full of impurities.
Correct. What kind of impurity? Let's go very simple. What kind of impurity are we talking about?
I mean, apparently it's limestone, according to this.
No, it's not. It's not limestone. You're wrong. It's not.
Yeah, I don't know.
It's simply dirt. Let's just say that. It's dirt. Okay, dirt. And dirt is, let's say, 95% sand.
Sand?
Sand. Yes, the kind of sand that you go into the beach and find, but it's from the underground.
Oh, this is sand, right?
No, that's limestone. No. That's limestone. That's limestone. Limestone is not the impurity. Limestone is what we add to remove the impurity. The impurity is sand. That's why I define the impurity first. The CaCO3 here is not the impurity. That one I can guarantee.
Mm.
So what's going on here? Where's the impurity? Let's go down one slide first. Let's go down one slide. There you go, SiO2. The SiO2 is the sand in the iron ore. See the phrase? The iron ore is dirty with sand. Sand is SiO2. I need the carbonate to help me remove the SiO2. Following so far?
Yeah.
So the CaO, where does it come from? The CaO. The CaO will react with SiO2, the dirt. It will form CaSiO3, whatever. That's a slag. Where does the CaO come from?
I guess you just need. I don't know.
Go up. Just go up. Just go up. There. There you go.
So you melt limestone?
Not melt, but decompose. Remember the question we did yesterday, the decomposition or the thermal stability of carbonates?
So you just melt until it decomposes.
But you cannot say it's melt because nothing melts here. It basically just releases CO2. Look at that. Look at the reaction. It's CaCO3, nothing melts. Nothing becomes liquid. It just releases CO2 and you are left with CaO, which is what we want.
Mm.
So do not remember melting because if that's your concept, it's very difficult to memorize this reaction. There is nothing that melts here.
All right.
Okay, you need to memorize these two reactions. Is what I'm saying.
Oh, there's more. Okay.
So three reaction on top for production of iron and the two remaining reaction for the removal of sand. I will address the elephant in the room, the acid base. The acid. Okay, you absorb first. You absorb first.
You cannot understand.
All right. So let's go back to the fifth reaction. First, I want to address the acid base thing so that it doesn't become an elephant. Down. Two more. There you go. Right. This is an acid base reaction. If you think that this is something new, it will bother you until the end. This is not new. Look at CO plus SiO2. This is acid and base. Which one's acid and which one's base?
CaO is acid.
Nonsense. Oh, you nonsense. Remember, you have a very reasonable mark from your end of year chemistry. I'm still quite proud. You should be quite proud. You learn acid base what in preparation for end of year?
Mm.
Do you see an acid and a base here in the form that you see, in the form that you recognize?
I don't.
Correct, because you forget about one thing. You forget about acidic oxide and basic oxide.
Oh yeah. Okay. I haven't revised my year 3 chem.
Now, CaO and SiO2 both are oxide, ma. So which one's the acid oxide and which one's the basic oxide, and how do we know?
I've forgotten about this. I'm gonna ask for about it.
Metal oxide is acid or base?
It is.
Which one? Sorry.
Metal oxides
are acid oxide or basic oxide?
Metal oxides are basic.
Correct. CaO and SiO2. Which one is the metal oxide?
Carbon isn't metal, so carbon is.
No, Ca is not carbon. You keep remembering Ca is carbon. Ca is not carbon. Ca is calcium.
I don't understand why they will name it Ca, because carbon is Ca.
It's very annoying. I know. Unfortunately, calcium also Ca. So carbon, they put it as C. That's why I keep reminding you. Carbon is C, calcium is Ca. I know it's annoying. I know. That's why I never blame you, but I have to remind you. That's the standard law. What else can I say?
Mm-hmm.
So CaO is calcium. Is calcium metal or non-metal?
Metal.
So CaO is basic oxide or acidic oxide?
Basic.
How about SiO2 then?
Acidic.
Acid and base law? I mean, in this case, do we have to explain why they react or not?
Nah.
Correct. The most basic thing about acid base is acid react with base. Ta-da! That's it, look.
Okay.
It's just that this doesn't release, doesn't have H or OH. You're more comfortable with that. I know, but there you go. Acid-base reaction.
Yeah.
Can you memorize these two reactions and then write it down, and then we can call it a no, we cannot call it a day. These two reactions, please. Are you ready, Irish? Eiko, are you okay?
Yes.
Or
Actually, I have a question, but I think I'll ask on.
Yeah, I'm ready.
all right. So Ines, please, you can ask now if you want to, Keiko, or you can ask something.
Hello?
Yes, Ines, go ahead and close the slide and then write the remaining two reaction. If you want to ask now, Keiko, I don't know. Yeah.
I feel like I can spend more time on this, but I'll just put it on the Jamboard lah.
Okay. So I don't answer first lah. If you're curious and you're not in a rush. So.
What's the limestone formula?
You do have to remember that. So let's say you don't remember that, you have to write down limestone first, not too bad lah. Or you make a guess, no? I suppose that's how.
Yeah, I'm guessing.
Right. That's okay for them. It is a memorization. So I suppose.
I mean, I can just work backwards because I know what the answer is.
It does work backward, right? So good for you. Good for you. That's a good way of doing it. That's okay. That's logic, right?
Yeah.
Eiko, your concern is part 4, right?
Yes.
What I can tell you is that part 4 is a very typical question, as in, I'm not saying that it's easy, no, it's not, but it's, they like to ask it this way. So it's good for you to understand the process, whether, by discussing it with me or by doing yourself. Good. That's how many marks. 5 marks seems more than usual, but okay, I guess.
There's this point R is the foot of perpendicular from P to L.
Right, you recognize that phrase from vector, but it's not vector, right? But I suppose it just mean that. Sorry, it just means that P and R is the height. If that makes some sense.
Yeah, it is.
Right. As I told you,
I don't.
Yes.
I don't know how to find that lah. Yeah. Although I need to find the equation of the line itself.
Yes, you must. Yes, you must.
Okay.
I think
it's a very long process.
After you do that, let me think for. No, after you do that, finding the R will be kind of not so difficult because then it's just a tangent normal thingy.
Okay.
Right. It is a long process. That's why I suppose it's 5 marks. Right. For you, Ines, I understand that the slack is a bit of memorization, so you almost got it lah.
Yeah.
It's supposed to be CASI, so you got that 2 reverse. That's all. CASI. That's all. So metal first, then non-metal. It's just the norm in chemistry. Right. Now use your logic to guess the state symbol.
There is no balancing, right?
It's all perfectly balanced, so it's easy that way. Right? So limestone
Hello?
is stone. Yeah, it is no balancing. Yeah, yeah, it's
Am I
already
lagging?
balanced. It's already balanced. Can you hear me? Can you hear me? Ines, can you hear me? Echo checking, can you hear me?
Yes.
Oh, okay, so Ines is lagging. Ines, are you okay? Can you hear me? Ines, can you hear me? Oh dear. Ines, can you hear me? Okay, Ines, can you hear me now? I think you're the laptop crashed. Echo, are you saying that you have not done too much of the something like part 4? It is kind of a bit new for you.
I think so, yes.
It seems reasonably common in A level, so I guess it's good for you. Yeah, it's good for you too. I can that those things I can say, right? Okay, A level do this, right?
Okay.
Right. So getting used to it is a good thing. Yes, Ines. Now I can see you again. Can you hear me?
Yeah, I got lagged out of the meeting.
I think yeah. So I think you got almost everything correct, right? Okay.
I'm not done yet. Yeah.
Yeah. So you just have to guess the slag. Okay. Now for slag, it's also weird. It's also liquid. It's liquid because then it will flow out. I guess that's a good perk. Secondly, the liquid does not mix with the Fe. If it mixes with Fe, then that's bad, right? We are not really moving into
Yeah, but
the
different
Fe.
density.
Something like that, different density, and then they separate. So I guess it works out fine. It works out great for the purpose of purifying metal. Purifying iron in this case. Now you seem somewhat comfortable with this. This is a big thing. It's a big thing in your paper. So I want to make sure that it feels okay for now.
Yeah, I'm confident.
Right. So your homework is the math one, same thing, but mix up the topic, okay? Mix up the topic. That's up to you.
I'll maybe do two topics.
2 topics is fine. Just get it, get yourself to shape, right? Get yourself to shape slowly. That's fine. But for chemistry, I want you to find 4 questions for blast furnace. 4 question non-MCQ. You're not allowed to touch MCQ. 4 question, most probably you have to look at 4 papers. So far, so good. But you only have to do 3. Why do I ask you to find 4 but only do 3? So that you are very certain that your paper makes a big deal out of it. Every paper have 1. But just do 3 is enough. Because after a while, it gets repetitive. I guess that's the good news. After a while, it's not very challenging. No? So they give you a lot of marks. It will always be there. But if you understand, not so complicated one. After a while. Okay. Find 4 questions, but only do 3. If you want to do 4, that's up to you. But at least do 3.
Yeah.
For Sunday, is your homework clear?
Sorry?
For Sunday. So
Yeah.
because we're not meeting Friday and Saturday, we'll tell Sunday. Sunday, your homework is clear?
Yeah.
Then I will see you on Sunday. Really good job for today. Any other question?
No.
All right. I'll see you on Sunday.
Bye. Have a good night.
Bye-bye, you too, Anish. Nico, unless you want to ask questions, so we can part ways first, and then I'll see you on Sunday.
Okay, one thing.
Yes, please.
In MF26 we have the what's that? Derivatives for
Tangent.
sine inverse, cosine inverse.
Yes. Tangent inverse also, right?
Okay, then now I'm doing an integration question, right? So it's a fraction. And then like the trigo is in the denominator lah. Should I consider using that like derivative in
Okay.
integral? I don't know.
Okay. So you're still talking about question 4, lah, the parametric one, right?
No, it's a integration question already.
Okay, show me the question, show me the MF26, so I can just say clearly whether you're thinking the right thing or not.
I'll just put that on page 12.
Yes, please. Page 12. Okay, so this is the integral, I understand. Now, which MF26 are you considering here? Please show
For
me.
part
here.
A.
Part A, right. So again, show me which. Oh, this question doesn't have any substitution. Nothing. He's not giving you any hint, is it?
For our block test, we're not testing on substitution or by parts.
So this question is from a paper or from.
Nanyang paper, yeah.
And the Nanyang paper doesn't mention anything about substitution.
Yeah, not tested.
Okay, right. So the MF26 that you're mentioning, could you please copy paste? Because you mentioned trigo inverse, right? So, that does not work immediately. Yeah, I don't think so. Yeah. Just to make sure. Okay. Okay, I'm gonna enlarge it. Yeah, I'm gonna enlarge it. Oh, you're already enlarging it. Sorry. So let's not clash here. You do the enlarging. Okay, I'm gonna move it up here. I'm gonna move it up. Right. Okay, thank you. Okay, let's say I don't follow what you're saying. Which one do you want to use?
I did try to manipulate some stuff, but it didn't work out. But can I even do this in the first place?
Yeah. So the
Like,
integration.
What if the X is like some trigo thing?
The integration is tough. The integration is tough without any hint. Without any hint. Let's go through our thought process for a while, right? Okay. Sorry, how many marks is this? Part A.
2.
Oh, goodness me. Right. Okay, let's go through our thought process for a while for integration. Like integration is never easy, right? Then you have a few things in our toolbox, right? So the by parts is probably not going to work very well here, right? Yeah. Frankly speaking, wait. I might be saying the wrong thing. Wait.
I mean, it's not tested.
Yeah, but the revision package explicitly exclude by part and substitution, really?
Yeah. So it's modified papers.
Let me think for a while. So going through our thought process, if there's no by parts and there's no substitution here, then you're left with a few other things. Simple manipulation by identities to somehow make it doable, right? So I'm not referring to the MF26 that you're referring here. I'm referring to the identities somehow, or what do you call it? Partial fractional. I'm sure that partial fraction is helping us here right now. So I tend to not think about the MF26 that you give me here, right? I think the most similar one is this one, right? The most similar one is this one.
Yeah.
But to do this, you must first make this in somehow a square, and also this cannot be just d theta. It must be d whatever is here. Because I hope you understand what I'm saying. So this is dx. So this is dx, right? This is dx. Integrate this and then become that. Now let's say I have 1/1 plus let's say, to make it not very confusing. So let's say 3x square, something like that. Okay.
Yeah.
That's 9x to the power 4. Right? So I make it into 3x square because I want the square. Then this d, the d here, better not be dx. That's wrong. This better be d, the differential of 3x squared, which is 6x dx. So I better have that.
Mm.
This one is not substitution, and this one not by part. This one is your first few integration, right? So if you're thinking of going this route, you must somehow make the square appear somehow here by changing it somehow, and then you must also have something extra here. That's the route that you can try. At this point, from reading, it doesn't look very easy. Don't know why, right? So in terms of reading, maybe this is not the question that you want to do first.
Okay, I arrived at this, but I don't think it's correct anyway.
You have root 2. How come you have root 2, Amma?
Because
Because you used identities, right?
yeah, identities.
How come you have root 2? Huh? This doesn't work. The one must,
Okay, wait. Never mind, I forgot. It's not.
yeah, the one must be 1 and it cannot be minus also. This doesn't work. Right. So for this to work, the 1 must be 1 and the plus must be plus. That one cannot. That one you must make it 1 first, but the minus is even worse. The one.
Yeah.
You can probably make this 1. You can probably factorize. You can probably do that. But the minus is unsalvageable. You cannot use this one because you cannot use that one.
Okay.
Right. Interesting challenge. In terms of exam, I won't do this, but in terms of practice, that seems good. So let's discuss your any other question.
As of now, no.
Right. If you're stuck with this one on Sunday, we'll talk about it. As of now, how do you feel with your training so far? This is exam training, right? How do you feel?
I think it boosts my confidence a bit.
You mean slowly but surely, kind of that?
Yeah.
Every time you do the paper, you don't feel like you are back to square one or you're going up and down, those kind of stuff.
Yeah.
You feel that last time you tell me the reading is useful, you still feel that the reading is useful.
Yes.
You also feel that even though Nanyang standard is high, but you feel like you're closing the gap, but slowly, I guess.
Yeah, I think it's the doing speed. That's the problem now, but Nanyang is also a bit tedious.
Correct. The doing speed will suddenly improve. I don't know how to do this. I don't know how to say that. Suddenly, after you closes enough gap, suddenly it'll improve naturally. That means you don't improve your doing speed by being fast. That's not how it works not at the very least. Not the least correct. You don't improve by rushing. Let me repeat how you will improve your doing speed. Let me just repeat this. What will happen is your thinking speed becomes faster than your writing speed. That means you know what's going on. Yeah. Currently, you are slow because your writing speed is faster than your thinking speed. You still have to think a lot. In that situation, your writing speed is not the problem. In fact, writing speed is never the problem. You write very fast anyway. The thinking speed is the problem. But it's a problem that you address slowly, one at a time. Suddenly, after enough training, this is harder than assignment, right? You know this, right? It's a mixture of all topics. Your brain is reorganizing itself into recognizing what you need and what you need to plug. then suddenly, so it seems, after enough practice, your thinking speed becomes fast. I don't mean the reading, I mean the when you're doing, you still have to think. Suddenly it becomes very fast. And then you have no problem anymore. That's just how it is settled. There is no other way that I know. I can tell there is no other way to improve our speed. If I'm wrong, you must tell me, then I can improve. But so far, that's all I noticed.
I mean, I'm still a bit concerned because I'm still exceeding time now. So I don't know if during the actual paper, I don't know if reading first would actually like, I don't know, slow me down. But I think I just need to do more practice now.
I think so. I'm telling you what I'm telling you just now, so that you don't regress. You are doing the right thing. The Nanyang standard is high, and they are very creative. So every time it seems that you encounter problems after problems after problems, but those problems serve to plug your skill gaps. That's what you need to do. So if your skill gap is sufficiently plugged, after a while, suddenly your speed improves. You can try removing the reading portion. That means you do it like everybody does it. You can make an immediate comparison.
Okay.
Instead of wondering, does reading help or not? It makes me feel better, but can I use better the time? If I maybe remove it a little bit, maybe I can. Why don't you try? Why don't you try? Then you can make a comparison for yourself. You don't just have to trust. Okay. Right. And but remember, for comparison to work, you have to mark yourself. You have to mark lah. So please mark that kind of thing. Right?
Yeah.
Okay. So don't get burnt out. No need to do too much. You're not in danger of doing too little.
Okay.
Keiko being Keiko, right? Okay. I'll see you on Sunday. And if there's anything else, you can ask.
Okay.
Right? Okay. Keiko, you're doing the right thing, right? Even if you compare once without reading with reading, that's still a good thing to do. That's up to you, right?
Okay.